This is lecture 4, topic volcanic landforms, material in chapter 12. I'm going to go over 6 examples of volcanic landforms. And as you'll see, not all of the landforms are volcanoes. And as a matter of fact, this first example is not a volcano. It is something called a flood basalt. Now, remember, basalt is an extrusive igneous rock that cools very, very rapidly from lava flows. Well, during geologic history, there have been floods of very hot and very fluid lava out of deep earth fractures. And flood after flood of lava that cools into basalt forms, layers. Now, the reason why you wind up with very fluid lava, flowing out of fractures is due to a feature called a hot spot in geology. So this is different than, in atmospheric science. It's an area of upwelling of the asthenosphere. Now remember, the asthenosphere in the upper mantle should be maybe 40 miles below the Earth's surface, or 90 miles, something like that, or 100 miles. But there are areas, right, where the asthenosphere comes very close to the Earth's surface, maybe within a half a mile or less, or a mile. And so you wind up with, this area of magma very close to the Earth's surface. And so through fissures and fractures, numerous fractures, you can literally have this very superheated lava flood and inundate vast areas. Now, the best example, now in this lecture, this is what I'm going to give you, are really good examples of each of these features. And the best example is the Columbia Plateau in Washington State. Here it is here, and it's the Columbia Plateau is just to the east of the Cascade Mountains, and this is pretty much the desert area of Washington. It extends into Oregon, a little bit into Idaho. And it's called the Columbia Plateau, all right? And lava flood after lava flood after lava flood has built up a plateau, which is an upland surface. And in this case, built up, an area, the plateau, 10,000 feet, all right, high. And these floods, all right, lava flow after lava flow, lasted, over a 10 to 15 million year period. Now, here's just a little, a piece of the Columbia Plateau. Here's the Columbia River that's incised into just a little portion. And you can actually see some of the lava layers. Here's one here, and here's one here. And this is all the basalt. Here's one here, and here's, another layer here. So we're not seeing the entire, 10,000 feet of elevation, just as much as the Columbia River has, incised into the plateau. And here's just another image of it. And again, you can see at least, one thick layer that was a lava flow, and at least another one here. And it's, eroded in certain places, so you can actually see exposures of the flood basalts. Now, I'm still talking about the same thing. There is a very unique feature associated with flood basalts, very characteristic feature, and it's something called columnar jointing. Right. And so within, each of these flood layers, very distinctive columns, the joint spacing or the fracture lines. And these are, vertical contraction cracks in flood basalts. And here's an example of, some of the Columbia River, Columbia Plateau basalt. And here's just another example here. And, in some cases, the columnar jointing or the columns are perfect. Look at this. They're just so perfect. They almost look man-made, right? But they're very, very distinctive features. Now, I want to tell you how these columns formed. It's kind of like mud cracks, right? You've seen mud cracks. Here's a nice picture of some mud cracks here. Basically, when you've got mud, with fluid, and then the fluid evaporates, the mud dries, and it's going to contract, and you wind up with a surface layer of these kind of, polygonal or octagonal contraction cracks. Well, this is kind of the same thing with the lava. Now, as the lava cools, it's going to lose fluid, and it's also going to contract. And so you just imagine now that you've got these, these polygonal or octagonal features, and just extend them down into the earth, 10 or 20 or 30 feet. And so you wind up with all of these columns. So Maybe you can see it here. This was a flood basalt actually in Northern Ireland that we had gone to. This was my son when he was a little boy. This is it. This is like and it's near the ocean where the flood of lava had actually come on in, and so the ocean has eroded it. And so you can actually see the tops of the columnar jointing, and they're almost like little octagonal features. So they are contraction cracks. And then with some coastal erosion, you can actually see the perfect columns. Right, a beautiful example of columnar jointing, and so characteristic of flood basalts. All right. So the second volcanic landform is a volcano. And as you're going to see, there really are only two kinds of volcanoes. So the first one that I want to introduce to you is called a shield volcano. And this is very similar to a flood basalt. You've got a hot spot, but in this case, the hot spot is on the seafloor. And you have floods and floods of lava, all right, one on top of another, and you wind up creating layers of basalt building up on the seafloor. And so instead of building up on the land, creating 10,000 feet of elevation, creating a plateau, you wind up creating, a broad volcano. And so you wind up with a hot spot, again, some kind of an upwelling of the asthenosphere, a mantle plume. And so these hot spots can persist for millions of years, all right, stay in the exact same position for millions of years, and just flood lava after lava after lava. So it's just, basalt layers building up, thousands and thousands of feet. And this is actually the example of the Hawaiian Islands. Right. Now remember, the Hawaiian Islands did not form at a plate boundary. They're formed right in the middle of the Pacific Plate, that giant Pacific Plate, and there has been a hot spot that has persisted for millions of years. Now, here's the island of Hawaii. It's currently erupted now, but this is when it wasn't erupting. Now, the island of Hawaii, this type of volcano is called a shield volcano, because once it finally emerges, thousands of feet from the seafloor, it actually, has a very, very broad dome summit. And so it almost takes the shape of like a warrior shield. All right, because it's kind of a domal shape. And that's why the Hawaiian Islands are called a shield volcano. Yeah. So here's the figure from your book showing the formation of the Hawaiian Islands. And so here's like a rising plume of lava. This is where the hot spot that's persisted for, millions of years. And then the Pacific Plate has been moving in a northwesterly direction over the hot spot. And so right now, the big island of Hawaii is active. It's currently emitting lava flows, and it's been doing that for decades now, and it's been erupting because it's right over the hot spot. But in the past, this area, this island here, this is Maui actually, this was over the hot spot. So the plate has moved, and so as the plate moves, you wind up becoming an island, but it becomes inactive. And so this is an older one that was once, over the hot spot. And so the island of Hawaii, actually, from sea level to the summit, that shield volcano, it doesn't look like much, but it actually has an elevation from sea level to 14,000 feet above sea level. And then, right, which is amazing, those floods of basalt on the seafloor have built up an additional 20,000 feet. So you built up 20,000 feet on the seafloor, and finally you made it above sea level, and the volcano is still building. And currently it's 14,000 feet of additional elevation, and it's currently very, very active. Yeah. So here's just kind of another image of the current island of Hawaii and the Pacific Plate moving in a northerly direction. Here's kind of the age here, and here are the famous Hawaiian Islands. But in actuality, here's the Hawaiian Islands that you know of, from Hawaii to Kauai, but actually they extend, all the way to Midway Island or Atoll. And so there are many more islands in this volcanic island chain. And as I mentioned, the island of Hawaii is the youngest, is currently over the Hawaiian hotspot, as it's called, that's persisted for millions of years. And here's the other islands that are now inactive. One point that I do want to make now is that it's really quite amazing when you think about relief. That's what we're talking about, difference in elevation. Relief on the seafloor is much greater than that on the continents. I mean, if you think of, well, here's sea level here, and if you think of maybe the Mariana Trench, which is, 35,000 feet or 7 miles deep, and then you think of maybe an island like, Hawaii, which is built up an additional, 14,000 feet of elevation above sea level. I mean, it's really quite amazing the relief that you have, on the ocean floor or in the seas. So, I mean, the seafloor definitely has, from sea level, down to the deepest ocean trench, 35,000 feet. And then you can add more for, above sea level. But, the highest point on Earth is Mount Everest. And so from sea level to the highest point, it was 29,000 feet. And so definitely the relief on the seafloor is 35,000 feet. And then you can add, elevation to, islands in the ocean. So that's really kind of an interesting thing. We didn't go over every single term, here, but there's an ocean trench. Okay. Yeah, so there is a second kind of volcano. This is number 3. So if you don't have a shield volcano, another kind of volcano, this is all you have really, are 2 volcanoes. This one is called a stratovolcano. Now this is the type of volcano that has the classic cone shape that you imagine a volcano to have. Now the other thing about stratovolcanoes that you absolutely need to know is that these are subduction zone volcanoes. These are the type of volcanoes that form along the leading edge of the continent where you've got subduction going on. And so all those like the Cascade Mountains and the Andes Mountains that I had given you examples, all of those individual volcanic mountains are indeed stratovolcanoes. Now, the thing about stratovolcanoes is that they're not just made up entirely of basalt rock, of lava flows, like the shield volcano or the flood basalt. That's just all basalt, and just kind of flooding on out over a vast area and building up. Now, in this case, stratovolcanoes can have violent eruptions. Right? It depends on the chemistry or the kind of the makeup of the minerals in the magma chamber. But sometimes they have very violent eruptions. And what can wind up happening is during an explosion, it can take the rock inside the earth near the magma chamber and just crush it in an explosion, and then just emit out tons and tons and tons of dust or ash. And so you'll wind up with, violent eruptions that just kind of, you wind up with tons of ash being laid down on the surface, building up a volcano. And then other times, due to the different geologic makeup of the chemistry of the lava, you'll just have lava flows coming on down. And then, ash and lava and lash and lava. And here they're just kind of showing you the layering of ash and lava. And that's why it's called a stratovolcano. It's stratified or layered. And it's believed that this layering effect, adds strength. So the volcano, can build up very, very tall and have this, classic cone shape. And here's an example of a volcano with this little crater here. And usually the crater is just, a relatively small central depression where you've got the empty vent. Right, so you'll have a little, little crater where the empty vent is. But of course, the crater will be filled up with, with ash or lava, when you actually have an eruption going on. There's a little puff of smoke coming out there. Yeah. I just want to give you some examples. Oh, there's literally hundreds, if not thousands, of examples of stratovolcanoes. Here's a very famous one. This is, famous Mount Fuji in Japan. Of course, that's subduction zone volcano of an island arc, and you can see beautiful Mount Fuji from Tokyo, and it's snow-capped in wintertime, and people like to hike it. And here's kind of another really beautiful example of an active volcano in Costa Rica. People like to go to Costa Rica and for vacation, and in the town of La Fortuna is a famous stratovolcano that's been erupting for decades. and you can actually see it erupting. So you can actually stay, at hotels and things like that. They're not expecting any violent eruptions from this, obviously, to let you stay so close. But it is kind of neat to actually see the lava, flowing down and, on an active volcano and stay there for vacation. Number 4, all right, is a volcanic feature. It's called a caldera. And this is, by definition, a huge central depression after a violent eruption from a stratovolcano. And so this feature is much larger than the crater, much larger than, the little central crater that once was, right? I've kind of added to this. Basically, what happens is, during a violent eruption, a very violent eruption, what can wind up happening is the volcano, the stratovolcano, can literally blow itself up. So after millions of years of, of eruptions, of ash, and then lava and building itself up, how many thousands of feet, you wind up with a super violent eruption that literally tears the entire volcano apart. The magma chamber, the asthenosphere, where you've got the magma, is all evacuated. All the lava becomes evacuated, and the entire thing just collapses on down into the evacuated magma chamber. And so I've kind of added to this diagram to kind of show you this would be the caldera, right, kind of outlined in black after the volcano is gone, and you've got, the magma chamber emptied on out. So, and this type of volcano, the stratovolcanoes, are known to have violent eruptions that, crush the rock to make the ash. But sometimes they're super violent, right? And they literally blow themselves up. Right? It's like almost like a atomic bomb. And the best example that I want to give you of a caldera is in the United States. It's a national park. It's called Crater Lake National Park. It's in southern Oregon, and it's in the Cascade Mountain range of volcanoes. So it's in the kind of the southern part of near Bend, Oregon. Now the thing is, it's in the Cascade Mountain range, and really, only the base of the volcano remains, and it's right now that caldera is about 5 or 6 miles in diameter, so it's much larger than what would be a normal vent. But it's kind of weird that this is a caldera. Here's an aerial view, so you can actually see the caldera and the former base or rim of the volcano. All right, but anyways, the volcano that once was a 12,000-foot one. It was called Mount Mazama, right, and it blew up about 8,000 years ago, right, creating Crater Lake National Park. Now the thing is, it's not a crater; it's a caldera. I mean, it's a national park with the wrong name. It really should be called Caldera Lake National Park. The thing is, since the magma chamber was evacuated, it's emptied, this is actually the deepest lake in the United States. Right, it's over 2,000 feet deep. And so that's pretty amazing, and it's very famous for its crystal blue waters. It's really beautiful colored waters because of the depth of the lake. But anyways, this little island here in the middle of the caldera, I'm going to show you in just a few minutes. That's going to be another landform feature. I think landform number 6. All right, volcanic landform number 5 is a volcanic neck. And it's an erosional remnant of an extinct volcano. And so only the main lava vent or lava chamber is left, after millions of years of erosion. And so what you've got to have is, a volcano that goes extinct. So the hot spot, right, the hot spot, has to dissipate or die out, lose its source of heat, or the hot spot moves on to another spot. And so when the hot spot moves away, the volcano will become extinct, just kind of like, what's going on with, the Hawaiian Islands. And then erosional forces take over, long geologic time spans. And so at one time, this was probably, a 10, 12, 14,000 foot volcano. And so this is, beautiful example. This is the most famous volcanic neck in the western U.S. And literally there are, dozens and dozens of examples in the southwest and really in the western U.S. This is in near the Four Corners area. It's called Shiprock, New Mexico. And really this volcanic neck, I mean, you can't really see the scale of it. This is enormous. It's still 7,000 feet tall. And you can actually see some of the columnar jointing, right, in the basalt. And here's some, other vents, that are, kind of radiating vents, that were bringing lava to the main vent. And so that's kind of neat. And another really famous example is in Wyoming. It's called Devil's Tower. It's not quite as tall as Shiprock, New Mexico, but you can see all the columnar jointing in the basalt, and it's an erosional remnant of a lava vent, right? So that all the overlying volcanic material is all eroded away, and this is just the resistant basalt. Now the columns, right? The columnar jointing. The columns are enormous, and they're perfect, and they're beautiful. And crazy rock climbers, right? This is what people do, okay? They actually, climb and maneuver and make their way on up and climb to the summit of Devil's Tower. So there's a beautiful example of giant columnar jointing. And the final landform that I want to introduce you to is called a cinder cone. And this is nothing more than a hill of ash. Now, being made up of only of ash, not made up of basalt rock, you're not going to get a giant cone. Cinder cones are usually only a couple 100 feet high, 100, 200, 300. This is one of the tallest ones. Well, this is actually the tallest one in the United States. This one is about 500 feet tall. But basically, what you've got to have is a stratovolcano in the area. And you just saw with Shiprock, all the vents, you can have, dozens and dozens of vents radiating out, for 50 miles, let's say. And so some of these vents can make it to the surface, and they can just, have a little explosion and crush up the rock. And from a little vent, it can rain ash. Right, rain ash, in a vent or so, and build up maybe 100 or whatever, couple 100-foot tall cinder cone. And that's why it's called a cinder cone. And so this one is a national park near Flagstaff, just near the south rim of the Grand Canyon, and it's called Sunset Crater National Park. And there's literally, hundreds or thousands of cinder cones in the area. And this is the same one. It's because at the top from, aerial view, there's a lot of sulfur. And so if you fly over it, you'll actually see kind of an orange or, orangey color to the top near the little crater or the summit. And that's why it's called Sunset Crater National Park. But in the distance, there are literally thousands of them. So, basically Flagstaff is, I don't know, maybe about 2 hours away from the south rim of the Grand Canyon. And so if you're from Flagstaff driving to the south rim, you'll literally see thousands of cinder cones. So when you do that, make note of that. Yeah, and the funny thing is, here's Crater Lake National Park, the giant caldera that I was just talking to you about in southern Oregon in the Cascades. It's incredible that after Mount Mazama, exploded 8,000 years ago, all right? It exploded everything. There was this one little vent, right, that rained out ash. It was actually able to build up and build up. Now this thing, remember, it's built up from 2,000 feet, okay? Being the deepest lake in the United States. So you wind up at the surface now with a little cinder cone, and it's called Wizard Island. Yeah, but it's kind of a neat example if you ever do go to that national park. Okay, end lecture.